Okay, we're starting chapter 11, which is about circles. So exciting, something new, different shape. Remember, circle is not a polygon because it has curves. Polygons can't have curves. So we're going to talk about circles today. And by the end of this video, you should be able to identify tangents, secants, and chords, and use properties of tangents to solve problems. So I just said a lot of vocabulary words. And if you notice at the top of your notes, I have them all written down for you. So a chord is a segment whose endpoints lie on a circle. So they lie on, both endpoints lie on the circle. So if you notice in the picture, AB is a chord because you have one endpoint on one end of the circle and another endpoint on another end of a circle. Another thing I want you to write down is an example of a chord is the diameter. Remember, diameter is something, and I want you to draw a diameter. It goes through the center of a circle. I'm going to call this circle A. And to write it out, we write it out like this. So instead of having to write circle A, you just draw a little circle and you put the letter by it, and that letter is significant because it tells you what the center of the circle is. So circle A means that A is at the center of a circle. So that's how you name circles. And diameter is a chord, meaning it goes through it. Both endpoints touch the circle, and what makes a diameter is that it goes through the center of a circle. A radius starts at the center and hits at one endpoint, so a radius is not a chord. So write that down. A radius is not a chord, because a chord, both parts of the line have to touch the circle. So this is not touching the circle. This is the circle. This is just inside the circle. So diameters, yes, they're a chord. Radius, no, not a chord. A secant is a line, and I want you to circle line because that's important. Line is different from a segment. A line keeps going. So if you notice the blue line L, this is a secant because, yeah, it touches the circle twice, twice, but it keeps going. That's really important. And that's the difference between a chord and a secant. Chord stops, secant keeps going. And I want you to write down that a line, remember, a line, we use those arrows to denote that it's a line. So let's call this point C and point D. So to name a secant, you would say CD, and make sure you have those arrows. Super important you put the arrows on it. Tangent is also a line, but it's a line that hits it only one time. So secant hits it 2 times, tangent hits it 1 time. Write that down, please, in your notes. So tangent, if you notice the green line M, that is, it hits it only once. So that's a tangent. And we're going to talk about this a lot. We're going to talk about tangents a lot. And the point where the line hits a circle, that's called the point of tangency. So the point where it hits it 1 time. First thing you're going to be doing on your homework tonight is identifying the lines and the segments inside circles. So for example, number 1, name all the chords that you see. Okay, well, chords is a part of a line that hits both the circle, 2 parts of the circle. So if you notice this line KM hits the circle twice, so I'm going to put KM, and it's important that you denote it with that it's a line segment with just putting the line over it. So we have KM. Are there any other lines that hit it twice? Yeah, this part, JM, does hit it twice. Once here and once here. So when I say JM, I mean I'm talking just about this part of the line, nothing else. Let's see, I think that's it. I don't think there's any more. Okay, so we're done with chords. Secant is a line that keeps going, and it hits it twice as well. So KM doesn't keep going, so it's not a secant. But JM is a secant. It's a secant and a chord, and you're going to write that it's a secant by making sure those arrows are on that line above it. So that means it keeps going. Tangent hits it only once, and if you notice, some people are going to put HM like this, and that's wrong. This is wrong, so don't write it like that. What you should do, though, to name a line, you need either 2 points or you need to write the italicized one. So you're going to write line M like this. So these are the 2 different ways you can write lines, either by putting 2 points on that line and making the arrows, or writing out line M and using the italicized letter. So line H would be incorrect. Diameter, we talked about diameter, goes to the center. So notice this is called circle L. So KM is the only diameter, the only line that goes through and touches the circle twice. And a radius, pluralized, is radii. So all the radii in this picture would be KL. This is a line segment, that's why we're just putting the line. LM. Are there any other ones that you guys see? I see JL. So there are 3 radii in that picture. You guys are going to do 6 through 10, and I will check 6 through 10 in class tomorrow. That's the first thing you guys are doing on your homework. You need to know the difference between a chord, secant, and a tangent. Some other important information about tangents, because this is mainly what we're going to be talking about. First of all, congruent circles are 2 circles that are exactly the same. So write down that they are exactly the same, and the reason why they're exactly the same is because of the radius, because they have the same radius. So if the radius is the same size, the circles have to be the same size. Concentric circles are coplanar circles with the same center. So here's an example. I would write down dartboard because that's going to remind me that concentric means that they share the same center, but one's smaller than the other one. 2 coplanar circles that intersect at only one point are called tangent circles, and that's because tangent literally means 1 point. So in math, so tangent 1 point. So here, if you notice, there's 2 different ways you can draw it. You can draw circles that look like this, and they meet right there, or you can draw 2 circles that are outside of each other. They're externally tangent right there. Okay. Super important thing that I want you to remember about tangent lines and the radius, or the radii, is that they are always perpendicular. Super important. And I want you to draw a picture to show it. Let's say, here's my tangent line. So I know it doesn't look like it in my picture, but you're going to say that's tangent. And you know now that tangent means it hits it only one time. So here is where it's tangent at. That's where it hits it. Here's my circle. If I draw from the center to, if I draw the radius or the diameter or whatever, if I draw a line through the center that hits it at that point of tangency, it always, always, always will make a right angle. Super important for the word problems that we're doing next. Thank you for drawing that down. Number 11. Early in its flight, the Apollo 11 spacecraft orbited Earth at an altitude of 120 miles. What was the distance from the spacecraft to Earth's horizon rounded to the nearest mile? To do that, this problem, we're going to start off by drawing Earth as a circle. And fun fact, the Earth's radius is about 4,000 miles. So you're going to write 4,000 miles for the radius. And fun, cool other fact, we get to draw a spaceship. That's my spaceship, I guess. And it says it has an altitude of 120 miles. So that means that that distance is 120 miles. And they want to know what was the distance from the spacecraft to the horizon. So we want to know what this is. That's a tangent line. And that's what we're looking for. So I'm going to call it X. And what did we just write down on another piece of paper? If the tangent line hits the radius, it's going to make a right angle. So what you're going to do from this picture is we're going to make a right triangle. Sweet. So if this black line that I drew to complete the right triangle is also another radius of the circle, and the radii are always congruent to each other. So if this is 4,000, then that means that this part also has to be 4,000. And this is a right triangle, so we're going to use Pythagorean's theorem to figure out how far away the spacecraft was from the horizon. 120 is not the answer. The horizon, they're asking for the tangent line. So c squared is this whole line right here. And if you notice, some people are going to say that it's 120 and be done with it. It's not. This whole hypotenuse is the 120 plus the 4,000. So it's really 4,120 miles. And a leg of the triangle is 4,000 miles, and this would be the other leg. So you could say x squared plus 4,000 squared equals 4,120 squared. And then you subtract from both sides. 4,000 squared is a big number. 4,120 squared is another big number. Subtract those two. 1, 2, 3, 1, 2, 3. And you get x squared equals 974,400. And then the last thing you have to do is square root. And you get that the spacecraft was approximately 987, let's see, to the nearest mile. Yeah, 987 miles from the horizon. Okay, so let's see. What was the distance from the summit to the horizon to the nearest mile? let's see. Okay, I'll draw the picture for you for number 12, and then I want you guys to do the math. So we're going to start off with Earth again. Circle. Mount Kilimanjaro. There it is. There's my mountain. Tallest mountain in Africa is 19,340 feet tall. So I'm going to draw a bigger circle. Sorry. Oh, I didn't mean to. Okay, well, whatever. Okay, big circle. There's my big circle. Okay, so the mountain is 19,340 feet tall. Feet tall. What is the distance from the summit to the horizon? So they're asking again for this tangent line, x. Okay, and if you draw the radius, there's a center, and draw the radius here, we have a right triangle because they always meet at right angles. Now, if you notice up here, 4,000 miles is the radius of Earth. Miles. We want to change it into feet. So you multiply, there are 5,280 feet in every mile. So if you multiply by 5,280, this time our radius is going to be in feet. So 2, 1, 1, 2, 1, 2, 3, 4. This is how big our radius is this time. Okay, so that means that this part is 2,000, oh gosh, how many is this? 1, 2, 3, 21 million feet, and this part is also 21 million feet. So try to do this one. I know these are big numbers, but you can use your calculator and figure out how far away Mount Kilimanjaro is from the horizon. Okay, the last thing we're going to talk about is that when you have cone heads, yes, these remind me of cone heads. Why is this freezing on me? No. Come on, Smart Slate. I believe in you. I believe. There we go. Okay. Oh, goodness. Okay, the last thing we're going to do is these kind of look like cone heads to me, so I call them this cone head property. When you have two tangents, and they come from the same point, so this is a tangent, and it hits the circle one time, and it hits the circle one time. So when you have two tangents from the same point, so this one comes from, they both come from R, start from R, then they're going to be congruent segments. Congruent. And that's this point right there. And that's hard to read. Okay, so the last thing I want you guys to do, I don't know, I'm sorry I can't delete that, but RS is going to be congruent to RT. So all you have to do to find the length of RT is you first set them equal to each other, and then you do your basic algebra. So subtract an n, and we get 3 equals 1n minus 1, add 1 and add 1, and you get that n equals 4. And some people are going to stop there, but you're not going to do your happy dance. You're going to go back and read the question. It wants you to find RT. These are both similar to each other. So SR is the same thing as RT. It doesn't matter which one you plug it into. I like this one. I think it's easier than this one, but you can plug it into it whichever one you want. 4 plus 3 is going to be 7. So 7 is your final answer. Again, I'm sorry, I don't know why this isn't erasing, but to set up number 13 for you, since they're both tangent and they come from the same point, all you would do is 4 plus 2a equals 5a minus 32. So what you're going to do to finish is you're going to finish 13 and 15, and then you're going to answer number 16, and I'm going to check it at class tomorrow. So we talked about circles. Name 4 vocab words that you just learned today. Ready, set, go.